We present SORT3D, a spatial object-centric reasoning toolbox for zero-shot 3D grounding using large language models. Consider the task of 3D visual grounding. Given a scene and a statement referring to an object in the scene, the correct object must be picked out. As previous supervised approaches suffer from overfitting, bad zero-shot performance, and are not designed for live deployment, we present SORT3D, which combines an LLM with a spatial reasoning toolbox to obtain a visual grounding system that is zero-shot, modular, and deployable for real-time navigation. Our pipeline consists of 3 stages. We first obtain the list of objects in a scene using a 3D detector. The system then takes a language query from which we filter and extract the relevant object nouns and adjectives. For each of the objects, we use a 2D captioning pipeline to obtain semantic features. Then, the objects are sent into an LLM prompted to use our toolbox containing spatial search functions, which outputs selected objects and waypoints into an action execution module. Zooming into our 2D semantic perception pipeline, for each image crop obtained of an object, we select the image crop with the highest clip similarity to the object name. The crop is then sent to an instruction-tuned VLM with a captioning prompt providing attributes like color, material, shape, and affordances to use in reasoning. Our object filtering pipeline extracts relevant nouns from the input query, then selects the nouns from the full object list that are more relevant to the query. Finally, the filtered objects and captions are sent to an LLM prompted to use a toolbox of search functions that are designed to abstract away any spatial and mathematical reasoning. The LLM uses the toolbox to perform multiple tool calls, and finally decides an object to navigate to. SORT3D achieves state-of-the-art zero-shot grounding on the Refer3D and the VLA3D datasets. We now demonstrate SORT3D in a real-life navigation setting. We begin with a mapping phase using a grounding dyno-based semantic mapping module. This module gives us a list of objects in the scene with their locations and bounding boxes to feed to the rest of the pipeline. After mapping the scene, we give SORT3D a navigation query. We can see how our unique approach to object-centric navigation allows us to disambiguate objects only by their spatial relations. In this scenario, we task the system with navigating to the table next to the bookshelf, then to the chair next to the plant. The system uses our spatial reasoning toolbox to successfully choose the correct table and the correct chair among multiple tables and chairs within the scene. Additionally, because we're using an LLM, our system is able to use common sense reasoning to find objects that are most likely being referred to through an indirect statement. Here, we inform the robot that we're sitting on the sofa, and we task it with fetching our finished print. SORT3D is able to deduce that the printer in the scene is the relevant object from which the robot can fetch the print, and sends navigation waypoints to the printer, then to the sofa. Finally, we demonstrate the role of our captioning module in allowing the system to reason about an object through its semantic attributes. In this scenario, we task the robot with fetching a board game from the shelf. Here, SORT3D goes through multiple steps of deduction. It first reasons that it must choose the correct shelf, which is the one that has board games on it. The LLM uses the object captions to determine the shelf described as having colored boxes on it, deduces that they are most likely to be board games, and chooses that particular shelf, demonstrating the interplay between semantic descriptions and LLM reasoning. Thank you for watching. Please check out our repo link below and in the description.